So, I've got something super cool for you today on SciComm with Mel. And when I say cool, I mean like potentially terrifying, but also really fascinating.
Oh man, you're really building this up. What do you got?
Well, you know how we're always talking about space stuff? Scientists just spotted this asteroid, right? And get this, it actually has a real chance of like hitting Earth in 2032.
Yeah, I heard about this. You know what's really interesting about this one? This isn't just any asteroid. This is actually, like, football field sized. We're talking about something that could cause some serious damage if it actually hit.
That's exactly why I wanted to dive into this with you today. I mean, should we be worried? Like, how big of a deal is this really? So let's get into it. Adrian, when exactly did they first spot this thing?
They first spotted it on December 27th last year, right at the end of 2024. And it was this observatory in Chile, the El Sos Observatory, that made the discovery. You know what's really fascinating about this is that just based on how bright it appeared in the sky, they were able to figure out that it's somewhere between like 40 to 90 meters wide.
Can you maybe put that into perspective for us? Like, what does that actually mean in terms of size?
Right, so think about it this way. At its maximum size, we're talking about something nearly the size of a football field. You know what I mean? And what's really interesting is that by New Year's Eve, it had already caught the attention of some really important people, like Kelly Fast at NASA, who's their acting planetary defense officer.
Wait, we actually have planetary defense officers? That's actually a real thing?
Oh, absolutely. And in this case, Kelly Fast and her team recognized right away that this was something they needed to keep watching because, the observations were showing this fascinating pattern. Like, this wasn't just another asteroid that would pass by and disappear from our monitoring systems.
So, what happened next? Like, what are we actually looking at in terms of risk here?
Well, this is where it gets really interesting because by January 29th, the International Asteroid Warning Network, and they're this global collaboration of scientists who work on planetary defense, they actually had to issue a memo, and what they found is pretty significant. There's a 1.6% chance this asteroid could hit Earth on December 22nd, 2032. And what makes this even more interesting is the potential impact locations they've identified. Like, they're looking at several possible areas: the Eastern Pacific Ocean, Northern South America, the Atlantic Ocean, Africa, the Arabian Sea, and even South Asia. But here's something fascinating about this asteroid's path.
What's that?
So it follows this really interesting orbit, right? It's what we call highly elliptical. And it takes about 4 years to complete one orbit. And what it does is kind of amazing. It swings through the inner planets right near where we are, and then it shoots way out past Mars, almost reaching Jupiter's orbit. Right now, it's actually moving away from Earth, and we won't see it come close again until 2028.
Oh, so we've got some time to figure this out?
Absolutely, and here's something really important to remember. These odds are probably going to change. Most scientists are pretty confident that as we keep tracking it, the probability of impact is likely going to drop to zero. We saw something similar back in 2004 with an asteroid called Apophis.
Okay, so let's talk about what could actually happen if this thing, if it did hit Earth. Like, what kind of damage are we looking at here?
We're looking at what scientists call a city killer category asteroid. But the chances of that are slim. This is more likely to end up in an ocean. The world is more water than it is land, after all.
How does it compare to other impacts we know about?
So the best modern comparison we have is this amazing event that happened back in 1908, right? It's called the Tunguska event. And what happened was incredible. You had this asteroid or comet fragment about 30 to 50 meters wide, and it exploded over Siberia. And get this, it flattened something like 80 million trees across 2,000 square kilometers. Just completely leveled them.
And this new asteroid, is it similar to that one?
Well, we don't expect it to leave a crater if it hits. What would happen is that it would explode in the atmosphere. But what's pretty cool is that when we calculate the energy release based on its mass and speed, we're looking at something around 8 megatons of TNT. That's more than 500 times more powerful than the Hiroshima bomb.
That's absolutely massive. So it's most likely going to hit the ocean? If it did, would that be better?
Well, that's a good question. An ocean impact would generally be less concerning. But, and this is important, if it happens near a coastline, we could be looking at potential tsunami risks now. And that's something we need to factor into our impact scenarios when we're doing these calculations.
So, given how serious this could be, what can we actually do about it? Like, do we have any way to stop something like this?
Oh yes, absolutely. And this is one of the most exciting parts because We've already tested one method. Back in 2022, NASA did this incredible mission called DART, right? They actually crash a spacecraft into an asteroid to change its path.
Wait, really? And, did it work?
It worked perfectly. It was the first time we've ever demonstrated that we could deliberately modify the course of a celestial object. And the really good news is that we could potentially use the same technique with 2024 YR4 if we needed to.
That's pretty incredible. Are there any other options we could use?
Oh yeah, scientists have some fascinating theoretical approaches too. Like, one idea involves using powerful lasers to vaporize part of the asteroid's surface. And what happens is, this creates this thrust effect that could push it off course. There's also this really interesting concept called a gravity tractor.
What's a gravity tractor? That sounds interesting.
So this is really cool. The idea is that we'd send up this massive spacecraft, right? And it would basically use its own gravitational pull to slowly, very slowly, tug the asteroid onto a different path. The best part about all of this is that we've got time on our side. Like, we've got years to plan and implement whatever strategy we choose.
And if none of those work?
Well, and this is really important to remember. Even in the absolute worst-case scenario, we'd still have enough time to evacuate any areas that might be at risk. But I really want to emphasize that we've got multiple viable options here, and we've already proven that we can do this kind of thing with the DART mission.
With all this talk about city killers and massive explosions, I'm guessing a lot of people are probably really worried right now. Should they be?
Oh, no, absolutely not. Like, right now, scientists are just doing what they always do, They're tracking it, and they're gathering more data to understand the situation better.
So, how are the scientists actually handling this?
Right now, there's this incredible collaboration happening through the International Asteroid Warning Network, right? And they're constantly monitoring it, collecting new observations, and refining their calculations.
How confident are they about all this?
The Planetary Society reports they're quite optimistic. The odds are really good that this won't hit Earth at all. Like, they're expecting that as they get more data, that 1.6% probability is probably going to drop to zero, just like what happened with Apophis back in 2004.
But they're still keeping an eye on it, right?
Oh yes, absolutely. That's exactly what NASA's Kelly Fast emphasized. The really important thing here is that we can detect these objects, we can track them, and we have the ability to make these predictions well in advance. That's really what makes all the difference.
After everything we've discussed today, I'm actually feeling pretty confident about how prepared we are for these kinds of situations.
Definitely. But how cool is it that we've come this far, right? Like, we're not just spotting these objects now, but we have the technology and the know-how to do something about them if we need to.
It's pretty incredible that we can track something millions of miles away in space with such precision.
Right? But it's not just the technology. Take a look at the global cooperation we're seeing. You've got observatories in Chile making discoveries, and then the whole world jumps in to analyze the data and work together on this.
So I guess the takeaway for our SciComm listeners is that while this asteroid is definitely something to keep an eye on, we don't need to lose any sleep over it.
Exactly. Like, this is a perfect example of our planetary defense systems working exactly as they should. We spotted it early, we're tracking it carefully, and we have plenty of time to respond if we need to. You know what I mean? It's actually kind of reassuring when you think about it.
Thanks for breaking all this down for us today, Adrian. This has been SciComm with Mel, and we'll catch you next time.